Have you ever wondered how communication happens on the World Wide Web? It's like a digital dance between two partners, the client and the server. This dance is choreographed by HTTP or Hypertext Transfer Protocol, which sets the rhythm and the steps for their interaction. In this dance, the client takes the lead, sending an HTTP request to the server. This request might be asking for a web page, submitting a form, or even uploading a file. The server then responds, providing the requested data or acknowledging the action taken. This back and forth is the lifeblood of the internet, enabling everything from social media interactions to online shopping. But like any good dance, it's all about the details. There's a lot happening under the hood to make this seamless communication possible. So let's dive deeper into this communication process, starting with the HTTP client request. Firstly, the client, usually a web browser, initiates a session with the server. This is the initial step in the dialogue between the client and the server. Think of it as a digital handshake. It's the beginning of the conversation. Now, how does the client know where to go and what to ask for? This is where the Uniform Resource Locator, URL, or Uniform Resource Identifier, URI, comes into play. The URL is like an address. It tells the client where the server is located on the vast landscape of the internet. The URI, on the other hand, is more specific. It not only specifies the location, but also identifies the particular resource the client wants to access on the server. It's like the difference between a street address and a flat number in a large apartment building. Constructing the URL or URI requires some planning. The client needs to know the protocol, HTTP or HTTPS, the domain name, the address of the server, and the path, the specific location of the resource on the server. It's like piecing together a puzzle. Each part must fit perfectly for the URL or URI to be valid and lead the client to the correct resource. But it doesn't stop there. The client also needs to specify the parameters. These are additional pieces of information that are appended to the URL or URI. They start with a question mark and are separated by ampersands. Parameters can include details like the language of the content or specific page numbers in a document. Once the URL or URI is constructed, it's like the client has a map to the treasure. It knows where to go and what to look for. The client is ready to venture into the vast ocean of the internet and retrieve the desired resource. After specifying the resource, the client then determines the action it wants to perform. This could be asking for data, sending data, updating data, or even deleting data. Each action corresponds to a different HTTP method, but we'll delve into that in the next scene. Next, the client chooses an HTTP method, or verb, to indicate its desired action. You can think of these methods as the language of the web, allowing clients and servers to communicate effectively. There are several common HTTP methods, each with its unique purpose. First up, we have GET. This method is used when the client wants to request data from a specified resource. It's like asking, "May I see your menu, please?" Then there's POST. This method is used to submit data to be processed to a specific resource. It's akin to saying, "I'll have the spaghetti bolognese." The PUT method is used to update an existing resource or create a new one. It's like saying, "Actually, make that a lasagna." Delete, as the name suggests, is used to delete a specified resource. It's like telling the waiter, "I've changed my mind, no lasagna for me." Head is used to retrieve the headers of a specified resource, without the actual data. It's like asking, "What's on the menu?" without the details. Lastly, we have options. This method describes the communication options for the target resource. It's like asking, "What are my choices here?" In addition to the method, the client also includes headers in the HTTP request. These headers provide additional information, such as the type of content the client can accept, the content type it is sending, and details about the client itself. It's a bit like specifying, "I'm vegetarian and I'm allergic to nuts." For some methods like POST or PUT, the client includes a body in the request. This body contains the data to be sent to the server. It's like writing down your order on a piece of paper and handing it to the waiter. Once the client has prepared its request, it's time to send it off to the server. This is done using the appropriate communication protocol, usually TCP/IP. It's like the waiter taking your order to the kitchen. And with that, our order, or rather our request, is ready to be processed. When the server receives the HTTP request, it begins processing it. This is where the magic happens. The server is like the conductor of an orchestra, ensuring that each request is handled in harmony with the others. Now, during this processing phase, the server is essentially attempting to fulfill the client's request. Whether that means fetching a specific resource, updating data, or creating something new, the server is on the job, trying to get it done. However, not all requests can or should be fulfilled. Sometimes the client asks for a resource that doesn't exist or requests an action that the server can't perform. In other cases, the server may encounter an unexpected error while processing the request. So how does the client know what happened to its request? Enter the HTTP status code. The HTTP status code is the server's way of saying, "Hey, here's what happened with your request." It's a 3-digit number that encapsulates the outcome of the request. Let's look at a few common ones. First up is 200, the status code for OK. This means the server successfully processed the request. It's like the server giving a thumbs up saying, "All good here, mate." Next, we have 404, the status code for not found. This is what the server sends back when the requested resource can't be found. It's the server's way of saying, "Sorry, I looked everywhere, but I just can't find what you're looking for." Lastly, there's 500, the status code for internal server error. This is the server's way of saying, "Oops, something went wrong on my end." It's the digital equivalent of a shrug, indicating that an unexpected error occurred while processing the request. With the status code generated, the server is now ready to prepare its response. But that's a story for another scene. For now, just remember, the status code is the server's way of communicating the outcome of the client's request. It's a vital part of the HTTP communication process, helping to keep the dialogue between client and server clear and efficient. The server's response also includes headers and sometimes a message body. As you might remember, the client sends headers with its request. Well, the server does something similar with its response. These response headers are meant to provide additional information, often about the nature of the data being sent back. For example, the server might include a content type header to tell the client what type of data it's sending. This could be text, images, or even a video file. The server could also include a content length header to let the client know how much data to expect. Now, there's also the matter of the server's message body. While not always present, this body carries the actual data requested by the client. For instance, if you requested a web page, the HTML code for that page would be in the response body. If it's a picture you asked for, then the binary data for that image would be in the body. The server then takes the assembled response, headers, body and all, and sends it back to the client. It uses the same communication protocol the client used to send the request, typically TCP/IP. This protocol ensures that the data is sent in a reliable and orderly manner, so that no parts of your requested web page or image get lost in transit. Once the server has sent the response, it's faced with a choice. Should it keep the connection open for further requests, or should it close it? This decision is based on a few factors, such as the server's capacity, its current load, and the client's needs. If the server decides to keep the connection open, it will include a connection keep alive header in its response. This tells the client that it can send more requests without having to establish a new connection each time. On the other hand, if the server decides to close the connection, it simply omits this header. Finally, the server decides whether to keep the connection open for more requests or close it. And that, my friends, is how an HTTP response is formed and sent. So, that's the step-by-step process of HTTP client-server communication. It all begins with the client, usually a web browser, initializing a session and constructing a URL to specify the desired server resource. The client then outlines its desired action through an HTTP method, such as GET, POST, or DELETE. Additional information is provided in the request headers, and sometimes a message body is included for methods like POST or PUT. The server receives this request and processes it accordingly, generating an HTTP status code to communicate the outcome. It may also include headers and a message body in its response. Then, it sends this response back to the client. Depending on the connection headers, the server might decide to keep the connection open for further requests or close it. Remember, every click you make on the web initiates this intricate dance of requests and responses. Isn't that fascinating?